Hey folks, a second little video in talking about combinations, and now we're going to talk about permutations. Permutation is kind of a fancy word, but again, it's another way of selecting items from a set. In this particular example, permutations, they're ways of arranging items in a sequence. So we're going to pick things from a set. We're going to select things, but here the order matters. Remember that in combinations, order doesn't matter, right? CD, combinations doesn't matter. Now I want you to remember with permutations, PM. With permutations, the order matters. Now what is a permutation? What does a permutation problem look like? It's very similar looking, right? And the wording can be very similar to a combination. Excuse me. So here's an example. I'm going to use superheroes again, but I'm going to use the DC ones this time. If these 6 superheroes ran a race, how many different ways could the top 3 finish? First, second, and third. Right? So if we had all these superheroes here, who do we have? We have the Flash, the Green Lantern, Wonder Woman. I guess I have more than 7 of them. I have this guy on the end here. We're not going to count him. I don't even know who he is. We're going to just select from these 6, right? Flash, Green Lantern, Wonder Woman, Superman, Batman, and Aquaman. And I don't know who this guy is on the end. We're not going to count him. So from these 6, what if they ran a race? Who would win? I don't know. The Flash only has one sort of superpower. He's fast. So I would kind of think that maybe he would win. Superman, he can kind of do everything, and Wonder Woman can kind of do a lot of stuff too. So I would put them in my top 3. So let's say that in first place was the Flash, and let's say Batman or Superman came in second. Batman would be kind of slow, I think. And Wonder Woman, she's pretty fast. She might come in third. So there's a group of 3. Now I have to ask myself, does the order matter or doesn't the order not matter? Well, let's look at a different arrangement. What if I had the same 3 superheroes, but they came in a different order? What if Wonder Woman came in first, the Flash came in second, and Superman came in third? That would be a different arrangement, would it? That would not be the same as the Flash coming in first, Superman coming in second, and Wonder Woman coming in third. So even though I have the same 3 folks, if I arrange them in a different sequence, that would be a different grouping. And so the order does matter, right? So if I had this group and the same 3 guys come in a different order, the order matters. And if the order matters, it's a permutation. PM. Permutation, it matters. So how do we do a permutation? Well, we basically look at the same procedure, right? I try to keep my procedures similar. We're going to use the same procedure almost to solve the problem. So how do we calculate the answer to the question? If these 6 superheroes ran a race, how many different ways could they finish first, second, and third? Step 1, we've identified that the order matters, so it's a permutation. So I'm going to write down a notation, but this time I'm going to put in a P for permutation instead of a C for combination. I'm going to write down NPR. We still have the same N. It's the pool size from which we select. We had 6 superheroes. I know there was 7, but I don't know who that guy was on the end. Right? There were 6 superheroes from which to choose who ran the race. And that is our groups. That was our pool size. And then we wanted to know first, second, and third. So we wanted to know the 3 places, first, second, and third. That is our group size, 3. So it's the same numbers, it's the same pool size and group size as our combination example in the previous video. But let's write those numbers now, and we've identified them. We had 6 superheroes, and we want to know first, second, and third. We want to know 3 places. And so now we're going to pick up the calculator to calculate the answer to the question, how many different ways could they finish first, second, and third? So let me switch over to the calculator, and we're going to put it in. But remember now, this is an NPR, not an NCR. So I'm going to put in my first number, my 6 for my group size, my pool size. Then I'm going to hit PRB. And again, my choices are 1 for NPR, 2 for NCR. But we've identified that this is a permutation. So we're going to leave it at 1, or I'm going to select 1 on the keypad down here. So now I have 6 NPR, so all I have to do now is enter my grouping size, right? Remember there were 3 places, first, second, and third, so I'm going to put in a 3. So how many groups of 3 can I arrange? How many different arrangements of 3 can I make from a pool size of 6? And now I'm going to hit enter. And it's a much larger number than we got from the combinations, because every different order is different, right? This guy coming in first and this guy coming in second is different than this guy coming in first and this guy coming in second. So we have a much larger range of possibilities. And so our final answer is there's 120 different ways that those 6 superheroes could come in first, second, and third. And that's how you calculate a permutation. Thank you.